do that. So, like I said, you can rely on this, and it can be very, very helpful. Now, there are similar ways to do this in Java, but nowhere near the simplicity. Very difficult. And sometimes you need to rely on this desperately. And it's there for you in C++. All right, so another destructor example. Let me close those windows that I don't need so they don't take too much space. So again, defining it very simple. There's a header file which contains the class file. There's an implementation file somewhere else which includes the header file, which then begins to define functions. All right. So very simple. This is the way you define your destructors. Simply saying, okay, this is the destructor, and this is what it's supposed to do. Like this one says. Perhaps in this constructor it says hello. Here, just to demonstrate the function, it'll say goodbye as soon as the point is going away, is destroyed. This seems to be very simple, but let's say a few words about the following. Let's clear this up one more time. All right. So, so here's the main function, right? So it's somewhere on the stack. When the program is invoked, before the function is called, its so-called stack frame or stack activation record is created so that the main function, here its compiled code, has access to this local scope. If main happens to call another function named foo, right here, some other function named foo, and that's another function that sits in memory, this function gets access to its own set of local parameters. And as soon as foo returns and says, okay, I'm done, this memory is going to be deallocated and is returned. So the program stack collapses. So we're back to main. Now, if foo was creating some objects in its local scope, like stack or string or vector or something else, right? It was creating some objects. It's interesting to know that, and I think I need to demonstrate that. Let me very quickly try this. Just say File, New Project, just brand new project, real quick. Right here. I don't know. Destructor demo, something like that. Destructor demo. All right. New empty project. Just quickly demonstrate this. CPP main.cpp. Okay, add that and copy and paste. Right, just take it from here and copy and paste. Okay, great. That worked. I'm not going to include anything because everything is like defined in one file. Class point, there is a destructor. Destructor is being managed someplace. Include point, I don't need that because this little example just has everything in one file, pretending that everything is in different files. Let's see if we can compile this. Okay. By the way, that's the reason why I always try to give you more or less complete examples so that you can actually copy and paste them and get something out of them. All right, so it works. So here's something interesting. All right, take a look at main, right? So what we expect is this: create an object of this type, right? And then say return. It means that destructor will be invoked. Okay. And so our expectations are that a destructor can be, the destructor will be, let me actually modify this a little bit to say integer x equals 1, 2, 3. All right. For the sake of demonstration here, then the next thing what I'm going to do is say if x is greater than 5, 6, 7 or something like that, then return 1. Okay, otherwise return 0. And let me make this a true condition. If x is like greater than 0, okay? So this is a true condition, x is greater than 0, I created a point, and I say, if that's the case, return 1. And that should be our case. Otherwise, return 0, all right? And we have little goodbye expected from our object. So not much interesting here. Build, right? Build, and quickly run it. Control F5, just run it, and there it is. Goodbye, right? So it's all working. Okay. But let's set up a breakpoint. F9.